today. Matt and myself are going to talk about engineering as a profession. So a little bit about ourselves. I'm Kent Jones. I have a Bachelor of Science in Mechanical Engineering from UMB. I graduated in 2018. While I was at UMB, I took a concentration in biomedical engineering. I currently work for Irving Oil, and this is a picture of my dog Henry. He's a little over 1, and he's a long-haired German Shepherd. Matt?
Yeah, hey everybody. My name is Matt Byer. I have a Bachelor of Science in Chemical Engineering. Also graduated from UMB in 2018. Also have a diploma in TME, which is the Technical Management and Entrepreneurship program within the engineering department. It's an additional few courses you can take. And I currently work for Greymont. And this is a picture of my dog Max, who is a golden retriever.
Does anybody recognize that dog? Yeah. Yeah. It's only been 10 years, so.
So what is engineering? So
all right, let's focus, guys.
So we tried this in the last one, but is there anybody that would like to speak up and tell me what engineering is? Same result. That's okay.
You got a big fat no from our class.
That's fair. I wouldn't have either. So essentially, engineering is the use of science and math to design and make things. And further on that is basically as an engineer, you are tasked with solving problems. So essentially, if we go to the next slide. So as an engineer, you are a professional problem solver. Your main ability and your main tool is to not only come up with solutions, but come up with creative and innovative solutions that can fix the problem. In any given plant or role, there's going to be multiple different ways to fix and get the desired outcome, but it's your job to present it to your managers or to your boss on what you believe the best and most efficient solution is. Furthermore on that, engineers get to create things. Now, whether you're a civil engineer or an electrical engineer, and civil engineers building bridges or structures, and electrical engineer wiring systems, there's just all kinds of different things you can do. And realistically, the nice thing with engineering is if you think of any product, whether it's a consumer grade product like a toothbrush or the fuel in your car or the electricity to power your house, possibilities are endless. And at some point or another in all of those things, an engineer has been a part of that project. So anything you could ever think of, an engineer has had a part of, and it just leaves you, limitless avenues of different careers and different jobs you could have in the future. And a nice thing about all that is, as an engineer, you have job security because of the different options you have. We need police officers to keep us safe, and we need firefighters to put out fires, but we'll always need engineers to build our bridges and to run nuclear power plants. So yeah, you can go to the next slide.
Good, great. Thanks, Matt. So yeah, as Matt mentioned before, there's multiple disciplines within engineering. I have listed here 6 of the more common fields. So civil structural, that's looking after the construction of like buildings, transportation. So think like roads, bridges, sidewalks, canals, and dams, things like that. Mechanical, so that's the design, manufacturing, and maintenance of mechanical systems. So you can think like rotating equipment like pumps, turbines, compressors, as well as static equipment as well, like pressure vessels, heat exchangers, things like that. Electrical, so Matt mentioned before, is the study and application of electricity, electronics, and electromagnetism. So think of like power generation. So like within a dam, you're going to have generators, and the generators are hooked up to the electrical grid, and they generate power for us. So also think like the power lines outside, that's power distribution, as well as like motors. So the next would be chemical engineering. So that's the use of physical and life sciences to convert raw materials and chemicals into more useful and valuable forms. So if we look at the example of like a refinery, that uses a variety of different processes to take crude oil and to turn it into a more valuable form, like gasoline, diesel, things like that, propane. Aerospace engineering, a little newer than some of the other ones we just talked about, is the design, construction, and science of aircraft and spacecraft. So we can think of like commercial airplanes, helicopters, rockets, as well as satellites and like the Mars rover as well. The last one on this slide is computer engineering. So that's the integration of electrical engineering and computer science in order to develop computer systems. So think about the interface between like software and hardware on computers. So as you can see here, the picture is a bunch of code. So computer engineers will write code. They're also heavily involved in the controls of robotics, as well as like AI. I've listed here, and this is not an extensive list by any means, other types of engineerings. So as I mentioned before, like I have a concentration in biomedical, so this is a subgroup of mechanical. So a lot of these, you may not necessarily be able to get, say, a degree in environmental engineering at every school, but you may have the opportunity to get, say, like a chemical engineering degree, and then maybe take a concentration in environmental, or even if you can't take a concentration once you graduate, you may have an opportunity to work as an environmental engineer. So the list here, we have agricultural, so that's like farming, industrial and manufacturing, that's obviously specific to industry. Biomedical, like I mentioned, I have a concentration in that. That is looking at like prosthetics, robotics, things like that. Bioengineering is different than biomedical. It would be more of a subgroup of chemical. So you can think of like genetically modified foods. So actually bioengineering would be one of the oldest forms of engineering, like through selective breeding of crops and animals. As well, we have listed here nuclear, ocean, petroleum, environmental, which we touched on a little bit. And then the last point is geological and geotechnical. So geological and geotechnical is different than civil. So where civil would look at, say, pouring concrete like in a slab onto the ground, geotechnical and geological is looking at the ground itself and making sure the ground is suited for pouring the slab of concrete. So some potential careers I've listed here, and again, this is not an extensive list by any means. Design engineer, so that's looking into like the particulars of a piece of equipment or a specific process, really down into the details. Project management, so that's looking after, you would manage a team of design engineers on smaller projects, or maybe just a project engineer, as well as looking sort of on the business side. So looking at managing schedule, cost, and the end users' expectations. We have technical sales, which Matt will touch on a bit later. Operations. So operations is, so once we have equipment that's been designed, it's been installed, and now we're turning it over, we need to start it up and start operating it like it was designed. That's where operations engineering comes in. So they look after operating the equipment, making sure that it's being operated properly and being ran how it was intended. Maintenance engineering and reliability, those are they're similar, but they're quite different as well. So maintenance engineering would more look after like day-to-day maintenance. So that might be like going around and oiling or greasing the bearings in your pumps. Things need to be done on a routine basis. Where reliability engineering is looking after the equipment over its entire life cycle. So that's maybe helping maintenance engineers set up their schedules for greasing their bearings, as well as determining when assets need to be overhauled. So, for example, like a piece of rotating equipment, it can run for say 100,000 hours, but then after that, the wear is going to be to a point that it's not very efficient and would be close to failing. So that's when reliability engineering would say, okay, now we need to take this apart and rebuild it. The last point here, becoming a subject matter expert, that really happens later in your career. So typically you would start as a design engineer, working on various types of equipment, different processes. And then as you advance in your career, you might find one area that you're really interested in, really like. So typically, a lot of people would go into like rotating equipment, becoming a subject matter expert in that. So they might start shifting as they progress through their career to only focusing on rotating equipment, and maybe even only a specific type of rotating equipment. Like they might only focus on pumps or say compressors, and even then might be even further, like a reciprocating compressor or positive displacement compressors. So I guess a bit of background on some experience that I have. I did a couple co-ops when I was at university. The first one was with the pulp and paper mill in St. John. I worked as a project engineer directly under a project manager. So my role as a project engineer is, like I mentioned before, design engineers look at the particulars and in the detail of each type of equipment. But on larger scale projects, it's not feasible to have the project manager managing all of the engineers. So in that case, that's when a project engineer would be assigned to the project. And so what I did was I worked with the different design engineers, took the relevant information that needed to be fed up to the project manager, and was the point of contact for the project manager to relay that information from the design engineers. After that, I did a co-op with a company called Hit Dynamics, and that was more in a research and development role. So while I was there that summer, we did the HALE certification on an Airbus landing gear. That was actually very interesting. So that was just one project, but we also did a few others that summer. And in research and development, you get to do both destructive and non-destructive testing, which is very interesting. Then once I graduated, I joined a company called Fluor, basically doing the same role I'm in now, which is design engineering. So when somebody at the refinery identifies the need to replace a piece of equipment, they then send that over to engineering, and that gets handed over to somebody like myself, who's a design engineer. And I would look after writing the technical portion of RFQs, request for quotations. So that's specifying the size of the equipment, the metallurgy, the design conditions. The design conditions are fed from process engineering. Then once we get the bids back, I evaluate the bids to make sure they're compliant with our technical specifications and write the purchase order. So now that the equipment's being fabricated by our vendor, we need to look at how do we remove the old equipment and how do we install the new equipment that's going to be arriving. So for that, we have to have work orders, and I'm responsible for writing the work orders as well. So that's my experience so far. Matt, did you want to talk about yours?
Yeah, sure. So one of my first jobs out of university, I worked for a company called ThermTest, where I was a technical sales engineer. So in that role, essentially your tools and your resources are either the products that your company manufactures or the services that they provide. So at ThermTest, we dealt with basically thermophysical properties, so thermal conductivity, diffusivity, specific heat, that kind of stuff. So clients would come to me with their materials, and they would basically want to measure their materials either at room temperature or different temperature ranges. And sometimes we're looking specifically for an instrument to pull that into their own lab, or they wanted to use our lab, which we had 13 different methods of testing. And as that engineer, it's sometimes also called an applications engineer. It's your job to make sure that they're getting the right method for the right material, because of different physical limitations of different materials. If you measure it all using the same way, or sorry, if you measure the same material 13 different ways, you could get 13 different numbers, but only one of those numbers is right. So it's just kind of understanding the concepts and the science behind what's going on and applying it to your client's needs is essentially that job. And now I work for a company called Graymont, where I'm a remote operations engineer. And as Ken said, in operations, it's your role to make sure that the piece of equipment or the process works as intended. So it's been fully implemented and it's my job to make sure that it stays up and running. And it's me talking to production supervisors or plant managers, making decisions on what moves need to be made to target certain levels of production, or if we need to go up in production or down, or it's kind of my role to facilitate that with the local on-site operators. Where I'm a remote operations engineer, I'm based out of Moncton, but I operate kilns basically across North America. So that's my experience now. So on to the next slide is high school prep. So now that we've talked about engineering and the potential careers, you need to know what you need to do to get there. So the first thing you guys need to do is, first of all, decide maybe what programs you're interested in. You know, if you want to take engineering, if you want to take sciences, or, you know, if you don't, I mean, I know this is specifically for engineering, but if you're not interested in sciences and you want to take some sort of other degree, it's still the same. You need to look at what prerequisites you need for each university program, and they're each going to be different depending on what university you go to. One thing in particular is that different schools are going to have different levels of grades that you need to get into that school. So I use the term grade point average, but that's essentially just what's your average, what's your high school average. So for instance, you know, St. FX, it's a school down in Nova Scotia, might have a lower or a higher requirement to get into than maybe UNB. So maybe they need a 75% average when UNB only needs a 65, or the other way, vice versa. So it's just things like that you need to keep in mind in setting yourself up for success. You know, if you know that you're not going to meet the grade point average going into a certain school, chances are they might accept you, but on the most part, they probably will not. So it's just keeping that in mind. Different engineering programs have different prerequisites. So yeah, that's the main thing with university and engineering in particular. And I would stress to you guys is take as many math and science courses right now as you can, because the thing is that it's only going to benefit you in the long run. If you know if you're going to do a career in sciences, but say you don't know what stream you're going to end up in, maybe right now you don't really like chemistry, but you get to university and you find a subsection of chemistry that you really like, but you don't have your grade 12 chemistry. Well, then what do? You either have to go back to high school to get your grade 12 chemistry, or you can't pursue this career that you thought you might be interested in. Just an example, I did end up taking basically all my high school science courses. I took biology, and just kind of keeping my options open. But little did I know that chemical engineering is basically the only discipline of engineering at UNB where you have to take a biology course. So I was very fortunate that I took my biology in high school, not knowing that I was actually going to need it. So just something to keep in mind and look into prereqs. And then the final point there is find a school that suits your educational goals and personal needs. So as Kent mentioned, different schools are going to have different programs and then different subsections of their program. So, you know, if you want, you know, an environmental engineering degree, then you need to find out a school that offers an environmental engineering degree program. So that's one thing. And the other one is that you want to make sure your personal needs are met. So if say your dream school is halfway across the country, but you don't want to live from home, those are two things you got to balance what you want to do. So it's just little things like that. Of the main thing when you're picking at a university, you got to make sure it's checking all the boxes. So we can go to the next slide. So things I wish I knew in high school. So as I've already mentioned, take the courses you need and more. So don't get stuck with only having the required courses to get out of high school, because if you want to pursue a post-secondary degree in practically anything, you need to keep your options open, because realistically, courses in high school right now, when you guys sign up for your courses, you don't have to pay for them. But when you leave high school and you come back, you will. So something to keep in mind. And it's a lot easier now, and life is a lot easier for you guys to take your courses now. So just get them now, get them out of the way. So second point there is study even if you don't want to. So a big component of university is having the ability and the skill of studying. So it may not feel like you need to study right now. Like you may feel like, oh, I've got a test tomorrow, I'll be fine. And I promise you, if you do that at university, you won't do well on that test and you might fail. So studying is a very important skill and something that I wish I had worked on in high school so that I could have been prepared for university. And it's going to be one of your greatest tools once you get there. And the last one is work hard, your grades matter. That kind of goes hand in hand, like with what we talked about earlier. You know, if you want to get into the right school, you got to keep your grades up. You got to be able to, present yourself a best case for them to accept you. And that also builds a strong work ethic and dedication to learning. And that's what it takes to be an engineer, and that's what it takes to get through an engineering degree. So it's just it's instilling that work ethic and that dedication is the main thing you guys want to do right now. So we can go to the next slide.
Perfect. Thanks, Matt. So yeah, like Matt mentioned, you've done everything now that Matt suggested. You've studied, you've got the good grades, you did all your research, you got the right prereqs, and you've got accepted into the university you decided to go with, into the program. So you got university, now what? So your first term, maybe even your first year at most schools now for all disciplines is going to be very generic. So this is when you're going to take like your first year chemistries, first year physics, your first year maths, and some of your first engineering specific courses like engineering communications. And engineering communications is where you'll learn how to effectively draw and write technical reports. For most of your technical electives, those won't be available until your third and fourth year. So like we've mentioned before, let's say you decide, you get into chemical engineering and you decide you want to take a concentration in environmental engineering. That's not a decision that has to be made right away. You can wait a couple of years, see if there's any other options you like, and you can kind of make that decision in your third or your fourth year, depending on what electives are required to get that concentration. And one thing that's important to remember is that it's never too late to change your major. You might get into your fourth year of taking chemical engineering and decide, wow, I really like environmental now. And you can always add on a year and take those extra courses to get that concentration in the environmental engineering. So one thing to keep in mind is engineering programs typically require a higher number of credit hours to graduate than most other programs. So you're probably asking yourself now, what is a credit hour? So essentially what a credit hour is every course gets assigned them. And a credit hour essentially is a way to measure how much effort you're going to have to put into that specific course. So a course that is, say, 1 credit hour, you might attend the lectures in the week and have to spend 1 or 2 hours outside of lecture studying for that course. Where a higher credit hour course, let's say 3 or 4 credit hours, you'll have to attend the lectures. There's probably going to be a lab portion associated with it in an evening as well. But you also have to spend now maybe 5 or 6 hours each week studying for that course. So basically, the higher the credit hours, the more time you should be anticipating spending on that material. A few things that you shouldn't forget when you're at university is to make friends. You're going to want to make friends that have similar interests to you, not only in school but outside as well. University is really the time that you really want to find your passion. You want to find a degree, a specific discipline, it can be engineering or not, that really you're interested in. Because once you graduate, this is likely going to be something you're going to be doing for a very long time. And as I mentioned before, don't be afraid to change your major at any point throughout your university career. So expectations as a university student, due dates are very important and you have to meet them. Unlike some high schools where a due date you might be able to get an extension, that's not going to happen in university. If you can't make a due date, you're just going to get a 0. So due dates are generally communicated on a course syllabus. And what a syllabus is it's typically handed out on the first day for each course. And it has all the important dates in which you have tests, midterms, whether or not there's going to be an exam at the end of the term. As well, it's going to tell you if there's a textbook that's required for the course and what their learning outcomes are for that specific course. So due dates, you're going to want to write them down. So however that's best for you to remember, whether you want to write them in your phone and set up reminders, or if you have a calendar that you keep in your room and you look at every day, it's very important to make sure you have those due dates written down so you can plan accordingly. Studying and self-learning, like I mentioned on the last slide, you're not only going to be going to lectures, there's an expectation that you're going to have to be doing some self-learning outside of the classroom, whether that's by yourself or in the form of a study group. And it's really important that you find a way to study that works for you. So whether that's you have to go to the library and put your headphones in and kind of just get in the zone, work for a few hours studying by yourself, or whether you find that studying in a group is the more efficient way for you to study. So then it's important to make sure you have friends that are in your program and taking similar courses, so you can always have that sort of study group as you're going through. As well, there's other options as well to study. So a lot of courses will offer tutorials. It might only be a few times throughout the course, or if multiple people are asking, but tutorials are put on by either the instructor or a teaching assistant that's assisting the instructor. And it's really important you go to these tutorials when they're offered, because in the tutorials, they might cover similar material or the same material that the instructor had taught in a lecture, but they might present it in a different way that you better understand. As well, in the tutorials, they might cover example problems that weren't necessarily on an assignment, but that will be on a test. So basically, by going to tutorials, you're just giving yourself another opportunity to hear that same material taught in a different way that might be more beneficial. And they might be presenting you with different example problems that are more relevant to what's going to be on your test or on your midterm. As well, there's tutoring options as well. So say there's a particular subject that you're going to the lectures, you're studying on your own, you're going to the tutorials, but it's still just not clicking for you. Don't be afraid to get a tutor, and try to get a tutor as soon as you recognize that you're starting to not understand a concept or fall a bit behind. Get a tutor as soon as you can. That tutor might just be able to teach you something in a different way than you've heard in the tutorials or from your lecturer. Important as well is to read the textbook. So you only have so many hours that you're going to be in lecture with your professor, and there's not enough time throughout the term for them to teach you every little thing that's important to the subject. So they're going to refer you either to the textbook that they've recommended or to other online resources. It's really important that you take the time to read through those textbooks. Not only is it going to fill in some of the gaps that the lecturer doesn't have time to prepare for, it's going to offer you some example problems at the end of each chapter. And generally, when you buy a textbook, you'll have the example problem. At the back, they'll have the solution. And depending on the textbook, they might even have a detailed solution of how to work out and get to that final answer. So basically, what I'm trying to say is take every opportunity that you can to really set yourself up for success in the tests and in your exams. So Matt, do you want to talk maybe about life as an engineering student?
Yeah, sure. So your typical Monday through Friday as an engineering student is going to be divided between lectures throughout the days, and then more than often labs basically in the afternoon into the evening. So lectures, as Ken said, in your first and second year are probably going to be very generalized. They're going to be your basic level engineering courses, which maybe is just telling you what an engineer does and what the different disciplines of engineering do. And then it's also going to be your basic physics concepts and more than not your basic math classes. And then as you progress through your degree and even into your second semesters, you're going to get more specific into your subsection of engineering. So maybe the basic concepts of chemical engineering or mechanical engineering, or if you're in computer science or computer engineering, you might take a computer science programming course or something like that. But it's, for the most part, it's going to be a lot of basic stuff, more or less the building blocks. And then, yeah, in your afternoons, you're more or less going to be doing a lab. Again, those are going to be your basic physics labs, chemistry labs, just kind of getting the basics established. And as you progress, you're going to get more high-level labs and more that are in tune with what the concepts you're learning. So generally, and I can speak specifically to chemical engineering, your labs are generally in tune or in line with the courses you're taking. So I know that I believe it was in my third year, I took a heat transfer class, and then I had a lab which directly correlated to the concepts I was learning about in lecture. So it's kind of nice. You get to maybe sometimes practice and physically see the concepts you're learning from the blackboard. So they're really good tools for learning and getting hands-on experience in the what you might be doing outside of class. And then outside of regular class and lab time, you're going to be studying, working on assignments, and preparing for tests. So just as we've talked about, you're gonna need to study. Studying at university is almost mandatory. Nobody's going to make you do it, but if you don't, you're going to you won't be successful. It's your main tool. And as Ken said, credit hours are directly related with how much time you should be spending on a course. And if you're meeting the time that they tell you to, you're most likely going to be successful, and maybe you might need to spend more time on other courses, and you'll be able to figure that out for yourself. And that's also, most courses are going to have a certain amount of assignments that are laid out in the syllabuses. And I know that in high school, Madame McKeel and Miss Cook probably give you guys time to work on your assignments, maybe in class. I promise you, your professors will not. Your professors are there to lecture, and they're there to teach you concepts, but they're not there to let you work. So that's going to be on you guys. That's going to be on your own time to schedule when you need to get those done. And then same with preparing for tests. So on the first day of every class, you're going to get a syllabus which lays out all your deadlines for the entire semester. So you're going to know when your first test is, your first midterm, and when your final is. So it's just going to be planning accordingly and scheduling, your time to study for these tests, and studying appropriately. So you're not going to want to leave everything to the last minute. You might feel like you can do that in high school, but I promise you're going to have way more stuff to do in university, and you're not going to be able to. And I'm not going to sit here and tell you that I was the best about always planning out my time through my university career, but I made those mistakes and I learned from it. And it's something that everyone has to learn for themselves. So I just, think about it now, and maybe start practicing scheduling your time now. And then another one is, if you're not at school, you might be doing a co-op. So a co-op is an opportunity to take a semester off from school and get to go work in the field. So you would apply for, say, at Irving Oil, say at the refinery, and you would go and work there as a student engineer for 4 to 16 months. You get some real world experience, which looks great on a resume, and it gives you some practical experience to take back to the classroom and maybe apply that and understand those concepts better. And you also, they're more than likely a paid position, so it gives you an opportunity to maybe make a little money, which is always kind of nice. And then as an engineering student, it's important to make time for things that aren't school related. So one thing that I really enjoy doing is joining a recreational sports team. Even if it's a sport you never played or something that you would be really think you're good at, just join it. They are recreational sports for a reason. They're as competitive as you want to make them. Get a group of friends, put together, if you've never played soccer before in your life, put together a soccer team. Same thing with, and they've got all kinds of different sports. Like they've got hockey, soccer, flag football, but I mean, they've got other things like water polo, and there's a sport called broom ball that I'll let you guys look up, and there's dodgeball tournaments. So there's all kinds of fun things. And even if you're not into sports, there's other options too. Like there's different clubs, like maybe within engineering there's a robotics club, or chess clubs, or there's different clubs specifically for video games. Like there's all kinds of things at university and all sorts of different avenues, and you'll find your niche and a group of friends that have similar interests to you. And just kind of going along with that is go to social events either on and off campus. Great place to network, make friends, and sometimes even meet your professors. Sometimes the engineering societies or other societies at the campus will put on events, and you'll get to meet your professors personally. So that's always that always goes a long way. So yeah, so that's kind of it. We can go on to the next slide.
Okay, great. So a few things we wish we knew in our first year of university. So the first point here is probably the most important. You do not need to be the smartest person in the room. And if you constantly find that you are the smartest person in the room, you should probably find a new room. By being the smartest person in the room, you're not really giving yourself the opportunity to be challenged and to grow. So it's important not to be the smartest in the room all the time. As Matt mentioned before, work ethic and dedications are the key to success. When you're in high school now is really the time to start developing that work ethic. and that'll really help you translate well into university and be successful. University is not a competition or race. You need to focus on yourself and do not fall for the trap of always needing to have the highest grades. If you're constantly trying to have the highest grades, you might find yourself sacrificing other parts of your life, like family and friends. And it's just grades. It's really not worth it. As long as you're doing well and passing, at the end of the day, you're going to graduate with a degree from an accredited university, and that's really what you're trying to accomplish. University is not easy. You will face challenges, challenging courses, as well as difficult concepts that you may not get on the first try. But if you work hard and dedicate yourself to the learning, you will be successful. So whether that's using some of the concepts we talked about before, like going to tutorials, doing peer-to-peer learning, or getting a tutor, those are things that you may need to try in order to understand a few concepts. Everybody's in this together. If you're struggling with someone or with something, chances are somebody else is also going through the same thing, and they may not understand the same concept as you. So it's important to ask questions both in lecture and as well. If you're in a study group, don't be afraid to ask some of your peers as well. Peer-to-peer learning is actually a great way to learn. It not only helps you, the person that's helping you might present a concept in a different way than your lecturer had that might just click a little easier. That's also a great opportunity for the person that's explaining the concept to really solidify for themselves that they know the concept by helping you understand it as well. So it's really a win-win situation when you're doing peer-to-peer learning. And the last point before we move on to questions is to make sure you make friends in your classes and find a group to study with. It's important not only to have a study group, but as well, the friends you make in university will likely be friends you have for the rest of your life. So that's an important aspect that's not necessarily around studying. So that's our presentation. Are there any questions?
Ask, like something that you've thought of during the presentation different from your actual questions? Do you want me to just pull questions from your list? Yeah, okay. Okay. Let's see here. Somebody wants to know if your jobs can be dangerous, and if so, why?
Yeah, for sure. So my day-to-day job is going to be, you know, I'm mostly in an office space where I'm controlling plants remotely, but that does involve some site visits. So I sometimes go to a plant we have in Havelock, which is basically outside of Moncton. You know, I try to go every month or so and check it out and see the guys on site. And there definitely is going to be some dangers that you have to be mindful of. Now, these dangers are generally mitigated with personal protective equipment, you know, hard hats, reflective vests, steel toe boots, like those kind of things. But it's also, you know, being aware of different dangers that are, you know, that might not necessarily protect you. It's different, like for my job, we involve basically putting limestone in a kiln, and we burn it at, you know, 1,000 degrees. So it's being aware of what's hot. You know, you don't want to touch stuff that's 1,000 degrees, and you know there could be falling rock, and it's keeping an eye out for dangers like that. And you know, it's important to be mindful of dangers, but it's also important not to be afraid of them, because as long as, you know, there's either safety precautions in place or there's some administrative controls to keep people from hurting themselves, you're really not at a very high risk. But it's just understanding the dangers is the main thing.
Yeah, my current job's very similar, mostly in an office, and a lot of the same risks that Matt mentioned there are applicable to the refinery as well. A lot of the processes work at very high temperatures, so any steel that's exposed that's hot, you want to be aware that it's there and make sure not to touch it. But also, like Matt said, there's really nothing to be scared of. A lot of times there's safeguards in place, whether it's your personal PPE or shielding to keep you away from the equipment. or as again, like Matt mentioned, administrative controls to make sure that you're not operating a piece of equipment in a dangerous range.
So we have some people asking about what kind of skills or like personal traits would be useful if you're thinking of maybe going into engineering.
Yeah, so communication's a big one, a soft skill that's very important, both written and verbal communication. If you understand something from a technical perspective, but you can't relay that information to the people that you're speaking with that may not have the same technical background, knowing that information isn't really an advantage at that point if you can't effectively communicate what you're trying to accomplish.
Yeah, that's definitely a big one. And another one that I like to push is, it might not be necessarily a skill, but it's, admitting either when you're wrong or when you don't know something, which goes basically hand in hand with both university and your professional career. In university, if you don't know something, just ask. Just ask a question. 9 times out of 10, there's going to be somebody else in the class that has the exact same question. And I don't know how many times I can count guys that when I was studying or I was in class and I didn't understand something and I was, too afraid to speak up, that question was on the test 9 times out of 10. And it's way better to say you don't know something and get it sorted out early. And that goes the same in your professional career. As an engineer, you have the responsibility to both keep the plant running like as it's supposed to and safely. So if you don't understand something and someone asks you to do something that can either mess things up or someone could potentially get hurt, that's on you. You need to say that you don't know something right away. So it's, it could be prideful and maybe sometimes it can be a bit embarrassing, but at the end of the day, we're all professionals and it just needs to get figured out.
There's a question here that says, was there anything in your courses that caught you off guard in university? Like you weren't expecting it, or just an experience that caught you off guard in university?
I guess for me in mechanical, I didn't realize how many electrical courses I was going to have to take. I think I ended up taking like 4 or 5. And for me personally, the electrical side, like electrical engineering, some of those concepts, although they're similar to mechanical, they're just harder to visualize. So that was something that caught me off guard in mechanical.
Yeah, and I think similar for me, it's just kind of different courses that you didn't realize you need to take. Like I mentioned earlier, I had to take a first year biology course, which, I took chemical engineering with the idea that I would primarily just be doing chemistry, and kind of even going the opposite way. Chemical engineering, in a sense, the actual chemical engineering part of it has very little to do with chemistry. And I know that probably doesn't make sense to a lot of you guys, but if you ever do take the program, you'll know what I mean. It's a lot of you learn the basic concepts of chemistry and then you apply those to a process, but you're focused more on the process and less the actual chemistry, what's going on. So I guess that would be the big surprise. It's just, it's hard to maybe understand fully what a program is until you take it. And that kind of goes hand in hand with what Ken said earlier. If you went into chemical engineering thinking like, oh, I want to be in a lab, I'm mixing chemicals all day long, like I think that's cool. That's not really what chemical engineering is, but that's okay. And you could switch into a chemistry program. Like you have all the prereqs. So it's just that was the main one.
The next question, what do you think was the hardest part about getting your degree?
I think for me, I guess just in particular, and Ken can probably echo this as well, is that every course has that, that one course. There's going to be a course along your university degree that, has a ridiculously high fail rate. And, it's a difficult concept, maybe either from the professors, very challenging, or the coursework itself is just a hard concept to grasp. And that's going to come up. Everybody's going to have that. And I would say, outside of just particular courses is the overall course load. Like Kent said, you're going to need a lot of credit hours to finish an engineering program, and it's just going to be managing your time effectively, and managing your stress levels as well is the big thing.
Yeah, I agree with everything Matt said. There's always that one course within a program that is just very difficult. Generally in engineering, they use like high level math, which is just hard on its own. And then exactly like Matt said, just the amount of work that you have to do and being able to time manage effectively.
Somebody also wants to know what the coolest machine you ever worked on was.
I've worked on a couple really cool ones lately. One that I just finished working on was a large compressor. It was a hydrogen compressor, so it takes it was what they call a 3-stage 4-throw. So there's 3 stages of compression, and it had 4 cylinders. And so the inlet to the compressor was at 100 psi, so like 100 pounds per square inch. And over the 3 stages, it developed into 2200 psi, which that's high pressure. That's considered extreme pressure. So I worked on replacing the frame for that compressor, and that was very cool because there was a lot of unique challenges with that. That compressor itself was quite old. It was from the mid 70s, and we were obviously only replacing it here in the 2021. So that had been like almost 50 years, more than 50 years since it had been worked on. So we were trying to minimize the amount of work while still getting a compressor that was going to last us for the future. So trying to identify where we can make changes that minimize the impact to other infrastructure around the compressor while still modernizing it to give us an efficient compressor when everything was done. That was very interesting.
Yeah, and for me, it's kind of, maybe less equipment specific, but with my job, I remotely operate, like I said, 4 different plants right now across North America, and each one just basically has their particular challenges, either with the actual construction of the certain kiln. Like I have a kiln that's basically, 50, 60 feet in the air, and it's upright. But then for the most part, all my other kilns are rotary, so they're laying horizontal, and they actually they rotate like this instead of the stone basically coming down. So each one of them basically has their own challenges, but I just think it's it's pretty cool. Like I'm dealing with temperatures of upwards of 1200 and 1000 degrees, and I'm moving upwards of 600 tons of lime per day, and I make adjustments to the kilns based on the quality and the certain specs for what the customers are looking for. And it's kind of, you get to, in some sense, some of my job almost appears like a video game. It's kind of like resource management, adjusting the different inputs and the outputs of your material. And it's pretty cool.
Awesome. Was there a moment where you thought you'd change degrees or career paths?
Yeah, definitely in my first year, once I realized how many electrical courses I was going to have to take and controls courses, yeah, I definitely thought about switching into to a different type of engineering that didn't have to take those courses.
Yeah, and I was similar. I think in that first year, it's either kind of a make or break year for a lot of people. I think the first semester, it's a lot of work going on and a lot of courses, so it can be quite stressful. I thought about switching maybe just into a science-based courses, and then maybe taking education afterwards. But essentially, I went to our chair of first years, and I think she was the chair of chemical engineering. She urged me to stick out the year and maybe just start taking some chemical engineering courses, and never look back.
There's another question here. Can you guys talk about, a lot of people are interested in like the labs and just kind of like how much time you actually spend in a lab, or if it's like stereotypical that you're always in a lab. Just touch on that.
Yeah, so I think it's definitely a stereotype that engineers spend most of their time in labs. especially in university. Typically, like Matt mentioned, your Monday to Friday, basically anytime between like 8:30 to say like 2:30, you're going to be in lectures. And then you may only have in your first few years like 1 or 2 3-hour labs, like maybe say Thursday and Friday evening. And the labs in your first couple of years are like Matt mentioned before, are like your basic science labs. So like a physics lab or a chemistry lab. And then as you move on through your program, they get more specific to each of your disciplines. So like for mechanical, like I mentioned, we had a lot of electrical courses. So we had quite a few electrical labs, like creating circuits, like simple circuits to turn on lights, or working with magnetism. But yeah, it's mostly lectures with a few labs. And then I'll let Matt talk more specifically about the chemical engineering labs.
Yeah, exactly. So the big thing, like Ken said, you have to start somewhere. You got to learn those basic concepts. But as you move through your program, generally the lectures or the concepts you're learning in lecture from your professors directly translate to a lab setting, which is nice. And it specific, I guess I can talk on the chemical engineering program, is that they basically took a larger scale processes, like, I guess specifically, like if you think about like maybe like an Irving oil like refinery, they have plants or like at a process scale in a lab. Basically, that would be similar to that. Not necessarily refinery, but different like smaller downscaled processes that you can physically make changes to. And the idea behind those labs is to take the concepts that you've learned in lecture and apply them and see, theoretically, what's supposed to happen, but in real life, what's actually going to happen. And if you make this change or you adjust this valve or if you change your temperature, you get to see the real world effects of your learnings.
And then I think we'll finish it off with one last question, but we talked a lot about how you might not know what you want to do in grade 10, 11, or 12. What made you guys like pick engineering right from high school? And like, yeah, what kind of drew you into that? Because maybe you didn't really know too much about it in high school.
Yeah, so for me, I always knew I'm obviously mechanical, so I liked machines and cars and kind of the design process. And as well, I'm sure you guys, if you haven't already, will take like aptitude tests. I don't know when you take them here in New Brunswick, but that basically suggest what potential careers might look like based on your interests and different education level selections. And so for me, it was a recommendation from one of those altitude tests was mechanical engineering. So I looked into it some more, realized it was something that I'd be interested in.
Yeah, and it's kind of similar to Ken. It's it's kind of the age-old trope that if you're good at physics and math, then take engineering. But I mean, it's more or less if you're interested with physics and math is the main thing to keep in mind. And for me, just in chemical engineering in particular, I was interested with looking at large-scale industrial processes and seeing how they work and making changes to them. And it's pretty cool that I get to run these kind of plants was the main thing that brought me to chemical engineering.
That's awesome. Well, I will let you guys go and have lunch, and then we'll reconnect for the next class at 1 o'clock. I just want to say thank you so much for presenting and giving them all this awesome information. I know that sometimes all this information can be overwhelming because you might not have even learned about chemistry yet. So, but it's just kind of something that opens the door for you to start thinking about before your course selection. So if you do ever have any questions, these guys are really good at answering questions and stuff. So if you ever do have questions, you can always reach out to me and I can connect you with them. But I just want to say thanks again for presenting, and it was a lot of good information.
Yes, thank you very much. I could see some eyes in this room being opened to possibilities with your presentation.
Awesome. Good to hear. Yeah, well, thanks guys. I appreciate your attention.
All right. Thanks, everyone. Have a good day.
Perfect. Thanks so much. See you later, guys.